let's look a little more at the concept of table storage in Azure, because I think if you understand the concept, you can probably find a way that this might be useful in an application. The idea of your Azure Table Storage is that it is actually one of the what we call NoSQL database solutions available in Azure. Now, the idea of NoSQL is really, it's one of those things where you want to know what it is so you can put it on a resume and sound really smart. Well, no, not really. It's a valuable concept. It says, look, relational databases have been the centerpiece of application development for decades. And they're great for what they do, but they're not the solution for everything. Sometimes you just need a way to very efficiently store data, and that data doesn't need to be related to any other specific data. So you don't have this concept of, well, relations and the need for a relational database. Thus you have NoSQL databases. All right, and the data is, sometimes you'll hear that it's good for unstructured data. Honestly, I don't particularly look at that because there's always at least some structure to your data. And we're going to look at what that minimal structure is that you need for table storage. Okay, but it centers around the idea of entities. Okay, and so I've got a table and I'm storing entities in that table. And as I mentioned before, they can be partitioned across multiple nodes, and you don't control the internal storage mechanism. If you're interested in it, there's a 3-level architecture for the way that storage happens. I'm not going to go into that. You can actually find very good videos on that are available from MSDN and from Azure. All right, but under the hood, right, your requests can be allocated across multiple nodes, which is really multiple virtual machine servers deep under the hood. All right, but it's going to be controlled by partitions. Okay, and so you define one of the again, sorry for the pun, key things that you do is you define that partition key in your data when you're using tabular storage, because as you go to massive scale, that's going to really dictate performance of the system, because you want to really spread that usage out across as many servers as you can for the amount of data that you have. Anyways, now what is important with this is that even though you hear the word table, and for me, when I think the word table, I am a relational developer, relational database developer. I think that's structured rows and columns, right? That's not really what table storage works. Table storage really works based on key value pairs. And that's what gives it the flexibility, right? So if you've worked with things like property bags, you may be familiar with the concept of key value pairs. It's a very flexible way of storing data. So I have an entity, that entity is going to have some properties, right? And I'm going to define those by defining the keys of those properties and what the values are for those properties. And different entities, even stored in the same table, will have different sets of those key values. But that's the thing, and I'm probably making too big of a deal of it, but it matters to me because that explains how this works. Right? That's how I can store different entities that have different schemas in the same table, because it's not really a table the way a relational database developer thinks of it. It's a collection of items that have a collection of properties. It's really the way it works. Okay? And in fact, let's take a look at a couple of examples to hopefully make this a little bit clearer, and I'll also show you what I mean about the fact that it's at least minimally semi-structured data. All right, so here's an example of data that may be stored in a person table, right? Or person entity, whatever you want to call it. We've got students and we've got teachers, and they're stored in a table. We keep one table for all of this data. Now, the one thing that you will notice that's common across all of these, went the wrong direction there. Let's try that again. That's common across all of these is that they have a partition key and a row key. That's going to be minimal, and that is the fixed schema that every entity that's stored in table storage is going to have. In fact, if you use the SDK that integrates with .NET or other languages, you're going to, when you store an object, you're going to create an instance of an object that derives from an object that has these two properties. So you have to have those two properties. Beyond that, it's whatever you define. Right? So in the case of a student, for example, here I've got a student. This student has a first name, a last name, an age, and a grade. So those are the attributes, right? Those are the key value pairs that are associated with that instance of a student, right? I've got another student, and my second student has some, but not all, of the same attributes, right? The age is not present in the second student. And as far as table data storage is concerned, that's fine. Right? Because it has, both of these records have the absolute key data. That's the partition and the row key, right? And then in the same table, maybe I've got a teacher. Now the teacher has a different partition key and obviously a different row key, and that's fine, and different data. Okay, now looking at that partition, okay, one thing, don't associate the partition with a specific type of data. In this case, in this particular table of example, it's pretty obvious that I'm partitioning by, students are going to go to one partition, teachers can go to another. I may well have, let's say I've got a massive school district, all right, or maybe I'm a national education system tracking, millions of students and hundreds of thousands, if not millions of teachers. I probably wouldn't want to partition it this way. Maybe I would partition, rather than partition by student or teacher, maybe I partition by geography. Tried to say geography and zip code together, that didn't work. Some geography approach, right? Maybe it's location, maybe it's postal code, whatever it is, right? But the key to the partition concept is that it does just that. Right? It's not a way of differentiating object types, it's a way of differentiating storage. And if it makes sense to differentiate storage by type like this, great. And it makes a good example. But I do want to make sure you understand that's really just a physical storage thing. Now again, the combination of the two, however you map that out, the combination of the partition key and row key has to be unique. So I could have student 287C and teacher 287C, although I'd never recommend that. My goal, anytime I have this, is always to have a completely unique row key. Then I don't have to worry about partitioning. Okay, but that's the key. You've got those two attributes, partition key and row key, that you're going to have. Any other attribute is entirely up to what data you need to store.